Hi, my name is Jake Campbell, and today we are going to learn about Chapter 14, Section 4 on continuity. Continuity is graphing without taking your pen or pencil off of the paper. These are three examples of continuous lines because point XC on all three of these graphs is on the line, and the line will go on forever in at least one direction. Next, we're going to talk about discontinuity. If the function is broken or not connected at x equals c, the graph is not continuous or discontinuous. If there's a break, hole, gap, or jump in the line at x equals c, it is discontinuous. All three of these are discontinuous for three different reasons. The first one, there is a hole at x equals c, so that is discontinuous. This one, there's an asymptote at c, so x can never equal c, and it will never be on the line because there's an asymptote there. Next, this one has a jump at x equals 3, so that is also discontinuous. And also, not all calculators will show a hole at a point. Like this one, not all calculators are going to be able to show that. Now we're going to learn about interior point continuity. A graph can be drawn around the point without lifting your pencil off the paper. Interior point can only be present when the following two statements are true. F of x must be defined for x equals c, or f of x must be defined for x equals t, and t being any number near c. When f of x is not defined for x equals t, there will be a hole in the graph, just like up here, where there was a hole in the graph. That's caused because f of x is not defined for x equals t. Right now we're going to learn about endpoint continuity. Endpoint continuity is when a point is continuous from the left end of the domain, which is A, or the point is continuous from the right side of the domain, which is B. So it's only continuous on one side. It's A when it's only continuous on the right side of the domain. So a function f is continuous from the right at x equals a, which means the limit of x approaching a is f of x equals f of a. Same with b. If a function f is continuous from the left at x equals b, which means the limit x approaching b is f of x equals f of b. These are a few examples of continuous solutions. F of x equals tangent x is continuous at every number between negative pi over 2 and pi over 2. That's the graph right there. From negative pi over 2 to pi over 2 is your window for x. And then f of x equals the natural logarithm of x is continuous at every number from 0 to infinity. And that's the graph for that, for your window at negative 2 to 2 for x. And then f of x equals sine x is continuous at every number from negative infinity to infinity. That's the graph of sine x. Lastly, we're going to talk about continuous functions. If f and g are both continuous at x equals c, then the following is all true. 1. The sum of f plus g is continuous. 2. The difference of f minus g is continuous. 3. The product of f times g is continuous. 4. The quotient of f divided by g when g is not equal to 0 is continuous. For example, if 2 and 4 are continuous at x equals c, then 2 plus 4, which is 6, is continuous. 2 minus 4, which is negative 2, is continuous. 2 times 4, which is 8, is continuous. And 2 divided by 4, which is 1/2 or 0.5, is also continuous. Thank you for your time, and may the force be with you.